MathKlik.
Mabuhay! How do quadratic equations model real-world situations? Are all solutions to a quadratic equation acceptable answers to problems involving quadratic equation? This lesson will focus on solving problems involving quadratic equations. In 1954, George Polya, a renowned Hungarian mathematics educator, authored the book How to Solve It. This book became a primary reference in teaching students how to become problem solvers. In this book, he suggested four-step rule in solving problems, which we are briefly presenting as read, plan, solve, and check. When we read, we identify all given information, including the question asked in the problem. When we plan, we think of strategy in solving the problem, present the unknown with a variable, write a thought process, and convert this into an equation. When we solve the equation, analyze the computed values, and decide which value to take in order to answer the question asked. And when we check, we can use different approach, such as, but not limited to, working backwards in order to test and retest our answer. These steps will be demonstrated in solving problems involving quadratic equations. Let's have this number relation problem as our first example. The product of two consecutive numbers is 156. Find the two numbers. When we read with understanding. Let's identify the given information and be aware of the question. The problem is to look for two consecutive numbers with a given product. For example, the numbers 5 and 6 are consecutive with product 30, and the numbers 9 and 10 are consecutive with product 90. Note that if two numbers are consecutive, the greater number is 1 more than the smaller number. Part of our plan is to represent the unknown. Representing the unknown means letting it with a variable. If we let n be the first number, then the second number is n plus 1. Using these representations, let's form a defining equation that will lead us to the equation. Our working equation is n quantity n plus 1 is equal to 156. Let us now solve the equation n quantity n plus 1 is equal to 156. Multiply n by n plus 1. Express the equation in standard form. Factor the left side of the resulting equation. Equate each linear factor to 0. Thus, the roots of the equation n quantity n plus 1 is equal to 156 are 12 and 13. But, are we going to accept both 12 and 13 as solutions to the problem? If n is equal to 12 and n plus 1 is equal to 13, their product is 156. That's okay. If n is equal to 13, n plus 1 is equal to 14. And their product is 182, which do not conform to one of the conditions of the problem. Hence, the only acceptable solution to the equation n quantity n plus 1 is equal to 156 is n is equal to 12, where n plus 1 is equal to 13. Therefore, The two numbers that we are looking for are 12 and 13. One of the beauties of math is that you yourself can check or verify whether your answer to a problem is correct or not. You don't need to wait for your teacher to tell you whether your answer is right or wrong. In checking, go back to the conditions stated in the problem. With these conditions, compare the solution. 12 and 13 are consecutive numbers. The product of 12 and 13 is 156. All these conditions were met. Therefore, our answers 12 and 13 are correct. Let's have this time a geometric relation problem for our next example. The length of a rectangle is 5 centimeters greater than its width. If its area is 36 square centimeters, find its perimeter. If after reading the problem and you did not fully understand it, read the problem again and again until you understand the problem. As you read, identify the given information and be aware of the question. In the problem, a rectangle is given. Its length is 5 centimeters greater than its width, and its area is 36 square centimeters. For example, if its length is 10 centimeters, its width is 5, but its area is 50 square centimeters. If its length is 21 centimeters, its width is 16, but its area is 336 centimeters. What we are looking for is the perimeter of a rectangle with area 36 square centimeters, not a rectangle with area 50 square centimeters or 336 square centimeters. To solve the problem, represent the dimensions of the rectangle. Let W be the width of the rectangle. Since the length is 5 centimeters longer, let's represent it with W plus 5. Using these representations, let's form a working equation that will lead us to the answer to the problem. The problem says that the area of the rectangle is 36 square centimeters. Hence, W times W plus 5 is equal to 36. Let's now solve the equation. First, apply the distributive property. This gives us W squared plus 5W is equal to 36. Convert the equation in standard form. Then factor the left side. Equate each linear factor to 0. Then solve for the values of W. The values are negative 9 and 4. It is important to note that not both negative 9 and 4 are valid solutions to the problem. There is a need to reject the value negative 9 because the idea of width is that it must assume a natural number, not a negative integer. Walang negative na width. Hence, the only acceptable solution is W is equal to 4. If W is equal to 4, W plus 5 is equal to 9. Thus, the length is 9 centimeters. Let us now answer the question, what is the perimeter of the rectangle? We simply use the formula for the perimeter of rectangle, which is twice the sum of the length and the width. Therefore, the perimeter is 26 centimeters. I leave you the checking process as student activity. Now, try solving these problems. The sum of two numbers is 19 and their product is 84. Find the numbers. Here is a suggested solution. Therefore, the numbers are 7 and 12. In a right triangle, one leg is 7 centimeters longer than the other leg. If the hypotenuse of the triangle is 17 centimeters, find the perimeter of the triangle. Here's the suggested solution. Therefore, the perimeter is 40 centimeters. For more matitinik tips, just click MathKlik. And please, don't forget to subscribe and click the notification bell for our next video lesson. See ya!